Now that we've talked about measures of central tendency in a set of data for a quantitative variable, we want to talk next about measures of spread. So if all values are the same, then they're all going to be equal to the mean and there is no variability. Nothing's different. Variability comes into play when we have values that are different from the mean, above or below. Almost all the data you'll ever look at has variability. And so we want to find ways to measure that. And we have the following measures of spread that we'll look at: the range, the quartiles, the variance, and the standard deviation. Now, range is probably the simplest, most straightforward way to measure spread. So kind of the first thing you do is you take the maximum value, subtract the minimum value. And that tells you what values your data covers. So if one of your variables in a study you've done is age, you basically look what is your age range, youngest to oldest in your group. And it's really strongly affected by outliers. Say you were looking at age and you had everyone, say you had 100 people, 99 of them, so everyone except one person is between the ages of 18 and 24. But you have one person in your study who's 80. Well, now your range is 62. Whereas most people in the study are between the ages of 18 and 24, and that range is 6. So you see how strongly an outlier can affect the range. The quartiles we talk about when we divide our data into 4 equally sized groups. So remember, the median divided our data into 2 equally sized groups, the bottom half and the upper half. The quartiles take it one step further and looks at that bottom half and cuts that in half to look at the bottom quarter and the next quarter. And then it takes the upper half and it cuts that in half to look at between half and 3/4 and then the upper and the last quarter of the data. So on a uniform distribution it looks like this. You have your first quarter of your data and then you come to quartile 1. You have the second quarter of your data and then you come to the median, which is also quartile 2. Then you have your third quarter of your data and you come to quartile 3. Then you have the last of your data and you come to your maximum. Your minimum is down here. And we can obtain the quartiles. The way we calculate them is basically the same thing as we calculate the median. Most important thing, you have to order your data first. You can't do any of this until you have your data in order, smallest to largest. Now quartile 2, as we said on the previous slide, it's just the median. So we already know how to find the median. Quartile 1, you look at all the data that's to the left of the median. Do not include the median in this. It's all the data that's all the way to the left of the median. And for that lower half, you find the median of that lower half. And that's quartile 1. To find quartile 3, you're going to take the data, the half of the data that is to the right of the median. Do not include the median. And you'll find the median of that upper half, and that's quartile 3. Now the 5-number summary takes this idea with the quartiles a step further. And you're going to include in a 5-number summary these 5 numbers: the minimum, quartile 1, the median, quartile 3, and the maximum. And one of the things that this gives us is the ability to find what's called the interquartile range, IQR, interquartile range. And that is Q3 minus Q1. And that's going to give us the spread of the middle 50% of the data. The outliers aren't going to affect that one. Okay? So the range gives you the spread of all of the data. The interquartile range gives us the spread of the middle half of the data. And then we can graphically display a 5-number summary on something called a box plot. You see here, we draw a line for the minimum, a line for quartile 1, a line for the median, a line for quartile 3, and a line for the maximum. And then we draw a box around the entire interquartile range. And the last thing that we do is we draw these what are called whiskers from that box out to the max and the min. And that gives us a box plot. So that's a visual display. Shows us the overall spread of the data and the spread of the middle 50% of the data, and where the median falls in that middle 50%. Is the middle 50% skewed one way or the other? So that central box plot, again, it gives us the interquartile range, Q3 minus Q1. And we've been using this word outlier. Let's formalize what exactly an outlier is. Well, if you take that interquartile range and you multiply it by 1.5, and then add that value that you get to the third quartile and subtract it from the first quartile, that will show you where your outliers can be. So let's see what that looks like. Say we have quartile 3 equal to 25. And we have quartile 1 equal to 7. That would make our IQR equal to 28 minus 7, which is 18. Now if we take 1.5 times the IQR, what do we get? 1.5 times 18 is 27. So what does this tell us now? This tells us that our suspected outliers are either greater than Q3 plus this number 27, greater than 25 plus 27, or greater than 52, or they're less than Q1 minus this number. So they're less than negative 20. So that's how we get what our suspected outliers are. And if you're looking for outliers, you really do need to actually do this out. You can't just look and say, oh, that seems really big to me. I think it's an outlier. May seem really big to you, but if it doesn't actually fall this far away from one of the quartiles, then it's not a suspected outlier. Okay, the last thing we're going to talk about as measures of spread or variability are variance and standard deviation. So we've already talked about range, we've already talked about the quartiles and the interquartile range. The last thing is variance and standard deviation. Okay, so recall when we talked about variability, we said that that exists when values are different from the mean. So each value's difference from the mean is what we call its deviation from the mean. Deviation just means it's different from. It goes away from the mean this much. And we're going to use those to calculate something called variance and then something called standard deviation. Now, when we talk about deviations, let's talk about typical deviations and what that means. So when we get to these numbers, because we'll get a number for variance and we'll get a number for standard deviation, we can start to interpret what that means. Well, typical deviation from the mean is what we're calling our standard deviation. If that number is small, so if a standard deviation is small, that means in general, our values aren't that far away from the median. They don't deviate from the median that much. So that means there's a small variability. Okay, if things don't differ that much, then it's not very variable. On the other hand, if we have really large values for a standard deviation, that means that those values are very far away, some of them, from the mean. That in general, things are much further away from the mean. So that indicates large variability. Now, one caution I have for you here. So when you talk about small values and large values, you're talking relative to your data. So if all of your data is in the tens of thousands as their values, say it's home prices, then a standard deviation in the thousands isn't going to be that large compared to if all your data is, between 1,000 and 5,000 and you have a standard deviation of 2,000. That's large relative to the data that you have. So you need to be careful when you're thinking of large and small. We're not thinking absolute, we're talking relative to what we have. And here are the formulas. So the variance is what we call S squared. So this is variance, S squared. And what we do is we take all those deviations from the mean. We take each value of x. So x sub I is the first value is x sub 1, the second value is x sub 2, the third value is x sub 3. The last value, or the nth value, is x sub n. So we take each individual value, we subtract the mean from it, and we square it. And then this symbol right here tells us add all those up. It's a sigma, it means sum it up. Add it all together. And then multiply by 1 over n minus 1, which is the same as dividing by n minus 1. N is the number of values. So what this does is it takes the deviations from the mean, and after squaring them, it adds them all together and divides by 1 less than the number of values there were to get our variance. And then if we take the square root of all that down here, so if we just go ahead and take the square root of everything that we've just done, we end up with S, which is our standard deviation. This is a value that you will use over and over and over and over in statistics. And it looks like a very complicated formula. Fortunately, technology will do this for you, and it will do it well. But you need to understand where the formula comes from, and you need to do a few by hand to really get a feel for what's going on and why we can use this to call it the standard deviation. Okay, so let's do an example of how we find the standard deviation and the variance. Okay, and when it says example from text, this is from the Moore text that we are using, and it's on page 50. So variance and standard deviation for this set of 7 values, and the values represent metabolic rates of 7 men. Our minimum number here is 1,362, and our maximum is 1,867. And our n is 7. There are 7 different values here. Okay. So what we've done is here's each of the 7 values in this column right here. Here we've taken each one and subtracted the mean. The mean is 1,600 for this small set of data. You can verify that yourself if you would like. And then we've squared each of those. So these should actually be exponents. Okay, those are exponents. We've squared them. For some reason it didn't come through correctly on the slide. And if we add up those squared deviations, what do we get? We get a sum of 214,870. So, if we take that sum and we divide it by n minus 1, we'll get a variance here of 35,811.67. I've rounded it to 2 decimal places. It actually comes out to be a repeating decimal. And then if I take that value and I take its square root, that will give me the standard deviation. And the square root of that, again rounded to 2 decimal places, is 189.24. So our standard deviation for that set of 7 metabolic rates for men was 189.24. Now, the last thing I want to talk about is how you would choose a summary, how you would choose which measure of central tendency and which measure of spread you use to describe a data set numerically. You want to remember, this is the key thing, is that outliers affect the values of the mean and the standard deviation. Those are not what we call resistant numbers. So they don't resist the influence of an outlier. The 5-number summary you should use to describe the center and spread when you have a skewed distribution or when the outliers are present. But when you have something that's reasonably symmetric, it doesn't have to be dead-on symmetric, but reasonably symmetric, and you don't have outliers, you would use the mean and the standard deviation to describe those.